Humanity has long been captivated by the idea of transcending its physical limits, and few creations embody that dream as vividly as Tony Stark's Iron Man suit. A marvel of fictional engineering, this sleek, powered exoskeleton grants its wearer superhuman strength, flight, advanced weaponry, and an AI-driven interface, all packaged in a near-indestructible shell. It's the ultimate fusion of human ingenuity and superhero fantasy. But as we marvel at Iron Man soaring across the screen, a question lingers. Could we ever build such a suit in reality? Let's dive into the possibilities, the challenges, and the tantalizing hints of what the future might hold. The core components. Fiction meets reality. To determine if an Iron Man suit could leap from comic books to real life, we need to dissect its key features and measure them against today's technology. The power source, the heart of the suit. At the core of the Iron Man suit lies the arc reactor, a compact, near-limitless energy source that powers its every function. In the Marvel Universe, it's a clean, portable powerhouse. In reality, we're not even close. Nuclear reactors offer immense energy, but are massive and hazardous, hardly suit-sized. Battery technology, while advancing with innovations like lithium-ion, lacks the energy density to fuel flight, weapons, and life support for more than a few minutes. A breakthrough in miniaturized fusion or some exotic energy source could change the game. But for now, the arc reactor remains a sci-fi dream. Exoskeleton and strength enhancement. The suit amplifies Tony Stark's strength to superhuman levels, letting him hoist cars and smash through obstacles. Real-world exoskeletons already exist, aiding soldiers with heavy loads or helping paralyzed individuals walk. Companies like Exobionics and DARPA have made strides here, but these prototypes are clunky, often tethered to external power, and lack the suit's fluid, compact design. We're on the right path, but the leap to a sleek, self-contained strength enhancer is still a distant one. Flight capabilities. Iron Man's repulsor-powered flight is a spectacle, agile, fast, and effortless. In our world, personal flight devices like jetpacks from Jetman or Gravity Industries offer a taste of this freedom, but they're limited by fuel, range, and bulkiness. The fictional repulsors, a form of energy-based propulsion, have no real counterpart yet. Electric propulsion or lightweight fuel systems might evolve, but achieving the suit's aerial grace remains a towering challenge. Weapons and tools. From repulsor rays to micro-missiles, the suit's arsenal is as dazzling as it is deadly. Modern weaponry, lasers, drones, guided munitions, shows we can pack a punch, but shrinking these into a wearable package is another story. Heat, recoil, and power demands make integration tricky, and the ethical implications of a walking weapons platform would spark fierce debate. It's possible in theory, but practicality and safety concerns loom large. AI and control systems. Jarvis, the suit's witty AI companion, handles navigation, combat, and more with seamless precision. Today's AI can pilot drones, analyze data, and even assist in surgery, but it's not yet at Jarvis's level of real-time adaptability and intuition. Still, progress in machine learning and human-machine interfaces suggests a future where a suit could pair with a smart, if less chatty, assistant. The feasibility, bridging the gap. So, could we stitch these pieces together into a real Iron Man suit? Let's weigh the odds. Technological advancements. The future looks promising. Nanotechnology could yield ultra-light, super-strong materials like carbon nanotubes or graphene for armor. AI is growing smarter, and robotics more refined. These fields might one day converge to make a suit conceivable. The energy dilemma. Here's the kicker. Without a revolutionary power source, the suit's ambitions collapse. Fusion, if miniaturized, could be the answer. But experts estimate that's decades, if not centuries, away. Until then, we're stuck with half-charged dreams. Engineering integration. Even with all the components, blending them into a lightweight, durable, heat-managed suit is an engineering Everest. It's not just about building parts, it's about making them sing in harmony. Cost and purpose. Who'd foot the bill? A real Iron Man suit could cost billions, demanding a clear payoff. Military defense, space exploration, or perhaps a billionaire's vanity project. looking at you, Elon Musk. Resources and priorities will dictate the pace. Ethics and safety. A suit this powerful could be a game changer or a catastrophe. In the wrong hands, it's a weapon of mass destruction. Regulations and safeguards would be essential, potentially slowing progress to a crawl. Stepping stones. Iron Man's real-world legacy. A full-blown Iron Man suit might elude us, but its pursuit could spark innovations that transform lives. Medical marvels, exoskeletons could evolve to restore mobility or supercharge workers in hazardous jobs. Imagine a firefighter lifting debris with ease or a paraplegic walking down the aisle. Augmented futures. Wearable tech with AR displays and AI could assist surgeons, soldiers, or first responders, blending human skill with machine precision. Prosthetic power. Advanced AI-driven prosthetics might mimic natural movement, drawing inspiration from the suit's seamless interface. Flight for all. Jetpacks may not rival Iron Man's flair, but refined versions could aid rescue missions or thrill adventurers. The verdict: a suit of ambition. Will humanity ever build an Iron Man suit? In its full comic book glory, probably not anytime soon. The technological hurdles, especially power, are steep, and the practical and ethical roadblocks are steeper still. But that doesn't mean the dream is dead. The quest for such a suit could drive breakthroughs that ripple across medicine, engineering, and beyond, proving that even if we never soar like Tony Stark, we'll still reach new heights. In the end, the Iron Man suit isn't just about metal and repulsors. It's a symbol of our relentless drive to push boundaries. And who knows, maybe one day, a real-life genius will step into a lab, crack the energy puzzle, and surprise us all. Until then, we'll keep dreaming, tinkering, and aiming for the sky, one innovation at a time.